In our sustainable ways of growing food class, we have learned that growing food isn't just about plants, it's about balance between people and the planet. We ought to give back what we are taking from the planet. Today, we'll walk you through the basic steps of growing food the sustainable way.
On the very first day, we were divided into groups to observe the many things in the field. We observed a variety of flora and fauna. We also concluded that the soil we were working on it is red, black, and clayey.
On the field, we saw a number of insects like spiders, grasshoppers, red ants, yellow spiders, bell crickets, and black garden ants. The flora commonly included some edible species like green beans, pumpkin, and carrot. Other species, such as Mexican fire plant, devil's beggar ticks, touch me not, parthenium, etc., were also observed in great numbers. Buffalo grass, which is native to Karnataka, could be seen in abundance. On the next day, we removed all the plants in the field, except the nitrogen indicating touch me not. We separated the parthenium from other plants due to its harmful implication to the soil. The cleared plot was then divided equally for everyone to work upon.
Tilling. This step is essential due to the various positive impacts it has on the soil. Firstly, tilling breaks the compacted soil, making it soft and airy, thereby loosening it. It mixes air in the soil, providing ample oxygen for plant root and soil microbes, and allows for better uptake of nutrients than in compact soil. This allows the young plants to rise and grow easily out of and into the soil that helps the roots of the plant to grow deeper, aiding its healthy growth. This step also allows water to enter easily, reducing runoff and increasing water availability to plants. However, it is important to note that tilling does not go beyond the first 2.5 inches of the topsoil. Digging deeper can cause loss of nutrients and essential microorganisms from the soil. It should also not be done excessively, as doing the same as can cause soil erosion, loss of moisture, and destruction of beneficial organisms. Thus, it must have done carefully at the right time.
Important step in treating soil is knowing what is already has. For this, we conducted two tests, soil fitness test and water retention test. The former involves knowing the composition of the soil. An ideal soil consists of 40% sand, 40% silt, and 20% clay. This test is done using a simple transparent bottle and water. The bottle is filled up to 25% with soil, while the rest is filled with water. It is then vigorously shook and then allowed to rest for at least half of the day. The results from our soil test were as follows: clay 57%, silt 18%, and sand 25%. On the basis, we were advised to put 4 kg of vermicompost, 3 kg of cocopeat, and 6 kg of neem.
Water retention test, which is used to find out the water holding capacity of the soil using a filter paper, funnel, beaker, and a conical flask. We found out the water our soil could retain by calculating the amount of water left after passing 100 ml of water through soil. The ideal soil retains up to 25 to 75% of water passed through. Retention could result in dry soil unable to hold vegetation, while soil is too wet, would exhibit growth of useful microbes and cause the plantation in the area to rot by cutting of oxygen supply. Our soil was able to hold approximately 24.8% of water in 2 minutes 12 seconds.
To soil treatment is mulching. This involves covering the land with dry flora and other organic matter devoid of seeds and wet material to protect the soil from damage and also to change the biomass of the soil. Mulching is one of the most sustainable and natural methods used in growing food. It supports soil health, water conservation, and plant growth without harming the environment. By covering the soil, mulching conserves soil moisture by reducing evaporation, helping the soil retain water for longer times. This reduces the need for irrigation, as the soil can now hold water for longer. Organic mulches like straws, leaves, glass clippings, and compost slowly decompose and add nutrients back into the soil, thus acting as a natural fertilizer. Apart from this, it reduces weed growth, prevents soil erosion by blocking sunlight and protecting the soil from heavy rains and wind. It creates a suitable environment for beneficial microorganisms and worms, which help treat the soil effectively. Mulching also has various ecological benefits as it reduces the dependence on chemical fertilizers, reduces farm waste after harvest, consequently reducing air pollution and increasing plant yield while providing lower maintenance. There are a variety of organic mulches that were used and can be used in treating soil, such as straw or dry glass, leaves, compost, soil husk, sugarcane bagasse, and wood chips. Live mulch, such as cover crops like clover and legumes, can also be used as these increase the nitrogen content in soil. The week after mulching, we saw a considerable difference in the soil color and moisture. It was full of earthworms and seemed full of life. The weed growth had reduced, and whatever there was would be
At separate times. First, we started off with coco peat. Its water holding capacity would improve the water retention, which would save irrigation water. Coco peat makes hard soil loose airy, improving root growth and soil structure. This could help us prevent waterlogging by allowing proper movement of air and water in the root zone. It creates a soft nutrient retaining medium, ideal for planting, seeding, hydroponics, and potting mixes. It slows decomposition and adds organic matter to the soil, improving long-term soil health. The next clause involved the addition of vermicompost. Vermicompost increases water retention and aeration and adds useful microorganisms to the soil. They add additional biomass and nutrients while also acting as mulch. The last step to treating soil including adding them neem. Neem is a natural pesticide and decreases weed growth. The ant infestation or plant faces was also rectified using neem. The soil was covered with mulch after each of these steps.
Finally, it's time for sowing. We plant the seeds at the right depth, give them enough space, and water them carefully. Then we wait, letting sunlight, soil, and time to do their quiet work. This really tells us about how sowing is a science as well as an art. Before touching the soil, we learned about seeds, their categories, and the techniques that help them thrive.
seeds are broadly divided into five groups: legumes, leafy, underground, propagation, and others. Each of these needs a different method of sowing. For example, legumes and most other seeds should be placed individually in small crevices. One seed per slot is ideal. Too many cause competition and the plants suffer. Leafy vegetable seeds, being light and tiny, are simply broadcast over the soil and then covered. Propagation plants like tomatoes and flowers begin their lives in pots before being transferred to the mainland. We also learned about crop arrangements: parallel, diagonal, and circular. Each technique has its advantage. Our group chose the parallel method because it made the field easier to manage. We prepared a slot, tilling, shaping borders, and creating footpaths. Walking on freshly sown seeds can damage them, so these paths were essential. Using the parallel method, we planted a wide variety of crops. For leafy, we planted water spinach, pink amaranthus, dill, coriander, fenugreek, kulfa. For underground, we planted carrots. For legumes, we planted French beans and okra. And for propagation, we planted cherry tomatoes, capsicum, marigold, balsam, and cosmos.
Some plants, like capsicum and gongura, didn't grow well, perhaps due to environmental conditions or timing. The leafy vegetables emerged first, followed by flowers, then tomatoes and legumes. We transferred the flower and tomato saplings once they reached the correct height. Everyone in the group took turning watering. In a few weeks, our leafy vegetables should be fully grown.
The next chapter in our learning was composting, a method that turns waste into nourishment. We dug pits measuring 2 into 2 into 3 feet. Into these, we added fruit and vegetable waste from a mortar, then covered it with rice husk or compost maker. This reduces odor and helps the texture break down. Within a week, the pits were alive with flies and insects. The peels darkened as dehydration and decomposition set in. Compost enriches the soil with nutrients and beneficial microbes without relying on artificial fertilizers.
The final method we learnt was preparing Jivamrita, a natural microbial booster for soil health. To make Jivamrita, we mixed 2.5 kilograms each
cow dung and cow urine, 1 kilogram of jaggery and gram flour, a handful of soil, and 100 liters of water. It must be stirred regularly, and after application on plants, the soil needs generous watering. After 2 weeks, the Jivamrita was ready to be applied. To see its impact on plant growth, we measured the length of our slappings before and after applying it. After a week, we saw that their size had almost doubled. Acquiring the ingredients took a trip to the market and a visit to local farmer. There we saw organic farming in action on a large scale, a reminder that while challenging, sustainable agriculture is far from impossible.
Amrit's organic farm showed us what sustainable agriculture looks like in practice. Set deep within a forested belt, his farm run alongside Srinivasan, a farmer engineer turned farmer, stood out as the only fully organic plot in the area. As they spoke to us, they shared the everyday challenges they face: pests, weeds, soil imbalances, and the need to prepare beds carefully. Lessons made clear when cracked carrots revealed the effect of improper weeding and overwatering. The farm used both drip irrigation and sprinklers across two elevations, and soil tests guided them in adding natural supplements like sagarika and agricole. The season's crops carrot, radish, beetroot, fenugreek, and coriander taught us about the difference in harvesting. Radish lifted easily from the soil, while carrots demanded careful digging. As they grew, 100 kilograms of produce, witnessing firsthand both the difficulty and beauty of organic farming. Listening to the farmers who chose their demanding path even when surrounded by conventional chemical based practices reminded us the sustainable agriculture isn't just a method, it's a commitment to shaping a better future.
On our last day of class, we harvested our produce. The tomatoes, carrots, most legumes, and the recently planted leafy vegetables had not fully grown yet. We did, however, the harvest the other leafy vegetable and some French beans. To avoid potential weed growth in our absence, we only harvested the head of the plant. We carefully cut out the top portion of the plant while leaving the stubs behind. The wood, this would ensure that the plant grew again, leaving fewer nutrients for weed to grow. The amaranthus and dill came in plenty. Almost all the water spinach was destroyed by millipedes and blackworms. The coriander was unfortunately taken by someone. Its harvest, though, was plenty. We also harvested a handful of beans and some of the figure leaves.
From this course, we learnt a lot about sustainable agriculture and the process that goes into growing our food. Farming is shaped by climate, pests, soil, and countless unpredictable factors. Yet, with care and understanding, it becomes a practice where both land and people grow. Sustainable agriculture isn't just a method, it's a relationship with the earth.